Hello, everybody, and welcome back to the Azure podcast. Today is August 18th, and this is episode number 435. And we'll be talking about HPC on Azure, which is high performance computing on Azure, with our special guests, Bill Paxson and Rob Futrick. I'm joined by my, couple of my usual, I guess, I want to say compadres, but like that's not negative enough in this context. But Kale and Sajid are here with me, and so let's go ahead and just get right into the news. Kale, looks like you put a couple of things out here.
Yeah, I got two here today. The first one is about Azure Data Explorer. We've talked about it on the podcast a few times, but this one specifically is talking about, the Custo engine that we have here, the third generation, and specifically talking about some of the gigome. I don't know how you pronounce that exactly, but basically some of the results for this report that was kind of generated to show the kind of the relative performance of like Azure Data Explorer with, I think it's like 1 gig, a terabyte, and 100 terabytes of data, and basically kind of compare and contrast that to other platforms that are similar in this space, such as Snowflake and things like that, the Google BigQuery. So it's a pretty cool write-up, and there's a full report there on, kind of the benefits of Azure Data Explorer in that context. Really interesting stuff for people who are playing in the big data space there. The second one I had is around the DevBox preview. So this was just
that sounds so cool, doesn't it?
Yeah. So for folks who don't know, the DevBox is something new that's been made public now, and you can get to it through the Azure portal. I think if you just search for DevBox, it'll come up there. There's also I think an external website you can go to get to it, but it'll basically provision you a DevBox and get the right size for it. You can obviously do things like custom images and things like that to get all the good tools on there that you want. But the idea is to lower the friction for developers who are in the IDEs or using SDKs to basically get the right set of tools they need to develop faster. It's all about the velocity there. Because this is running in Azure for compliance and security and things like that. So pretty cool stuff.
That's all. And then I was going to add in for AKS, the container storage interface, which is CSI, is allowing you to use Azure Blob Storage as your persistent storage for AKS, but you're using the CSI driver, which is basically an interface, so a standard mechanism for doing this. I know a couple of customers that are using, third-party storage appliances as basically their persistent storage for their AKS clusters. And they would really like to get away from that and get to blob storage, because now they're just, using that native PaaS service at that point. They don't even need to worry about the infrastructure underneath it at all. But now you can do it natively rather than having to write something custom or use, a third-party thing to make that happen. So a nice advancement for AKS. Cool. Well, that looks like the news that we've got for this week.
Evan, I wanted to throw in one real quick. And sorry, I didn't have it in before to the OneNote, but this is one that I particularly like, and it's about the new basic logs preview that we have coming out for log capturing. So typically, when we capture logs with Azure Monitor, they go into log analytics. There's, the ingestion costs can be pretty high, and often we have debugging turned on applications, and you can imagine the amount of volume of logs that go in there, and there's that high cost. And for the most part, those logs those debug logs, you're not really looking at storing them long term or doing some kind of analytics. You just want to look at them for debugging real quick, and you're probably not going to need them beyond a day or two. So there's a new plan called the Basic Logs plan now, and you could allocate some of those debugging logs kind of traffic to that, and the ingestion costs are much lower for those logs. Of course, they don't have the full life cycle as the regular logs, in terms of being able to do all sorts of fancy queries and whatnot. But at least they're available over there, so you can go in and just take a quick look at them if you have some problems. So I think that's something that's much needed, the Basic Logs feature, and they're rolling out that preview to some of the regions right now.
So this basically, I want, because I saw something about this, and this sort of speaks to one of the things I talked to customers about all the time. Because again, I live in the world of broken, so logs is a thing. Like nothing kills me more than, hey, we could troubleshoot this, but we don't have the logs, right? We have to wait for it the next time. So this is what sort of conceptually something like you could say, hey, a 48-day rolling, I reduce my cost.
It's basically 8 days. 8
I'm
days
sorry,
is the max.
not 48. Yeah, 8 days.
Yeah,
But it's like
8.
a rolling window, and if I'm willing to say I don't have it in 2 weeks, 3 weeks down the road, I'm able to really reduce my cost.
Yes, exactly.
Nice. Yeah, that's convenient. That's good. I will go on the record saying that and again, I'm not saying that cost doesn't matter. So no, don't flame us in the comments on this show, but like I very rarely have had anybody that's come back and said, man, I'm really happy that I was able to debug that outage real fast, but man, I'm unhappy about what it cost me to have the log when I needed it. Right. So philosophically, I always land on the side of having more rather than less, but absolutely acknowledge there's a cost with everything for sure.
Yeah. And there's a downside to it as well. As I said, that not all kind of fancy KQL queries are supported with it, and you cannot create any alerts of these logs. So this is primarily you're just there for doing some quick troubleshooting or debugging.
Okay. Nice. Cool. Okay. Awesome. Well, with that, let's get over to our topic of the day. Bill, Rob, can you guys introduce yourselves and tell us what you do for Microsoft?
Sorry, you want to go first, Bill?
Sure. Thanks, guys. I'm Bill Paxson. I've been here at Microsoft for coming up on 10 years. And I've worked as a support engineer in Azure, in the IaaS support space, then as a technical advisor. And then a few years ago, I had the opportunity to help build a new support team here at Microsoft, specializing in supporting high performance computing and a couple of other low volume but high consumption workloads. And so now since March of 2020, I've been managing this new support team, and it's been a real privilege.
Rob?
Cool. So I'm Rob Futrick. I'm the product manager lead for Azure's HPC and AI software and services team. Monday was actually my 5-year anniversary, August 15th. And I came to Microsoft through an acquisition, actually. So 5 years ago, they acquired our company, Cycle Computing, which is where one of the products that we manage comes from, Azure Cycle Cloud. And I was at Cycle for 12 years. So in some ways, it's my 5-year anniversary, but it's really also my 17th anniversary. And we've been doing, we started off doing on-prem HPC because in 2005, there wasn't cloud, but we rapidly pivoted over there. And our customer base kind of never went back. And so now we're here at Azure, and kind of our overall mission is to provide all the software infrastructure that people need in order to run AI and HPC workloads. But really, it's to simplify the entire process of running these kinds of workloads and enable our customers to do more.
So let's start out with you mentioned HPC and AI workloads. Let's just sort of back up just a little bit.
Mm-hmm.
When we talk about, I think everybody sort of has a working sense of what AI workloads are in this day and age. HPC's been around for a long time, but it's probably worth defining. Like when you say an HPC workload, what are you talking about?
Yeah, so Microsoft takes a pretty generous definition of HPC, which isn't a problem. It's really, if you talk to traditional people doing weather modeling and physics simulation, things like that they kind of their workloads, things have been running since the 60s.
I started doing CFD earlier.
Oh, there you go.
Fluid dynamics early in my engineering career. So yeah. And I'm old. So based on the gray, I'm old. So
so yeah, these things have been around for a long time. But more simply, it's just taking lots of computing resources, whether it's memory, CPUs, GPUs, networking, storage, you name it, and combining them together in order to solve kind of computationally intensive problems. At Microsoft, that includes things like weather modeling and CFD and physics simulation and all that stuff. It also includes, risk modeling, Monte Carlo simulation for banks and insurance companies and whatnot. It includes movie rendering. Anybody who really wants to run a very, very large, well, it doesn't have to be large, it can be small, but small to very large distributed system to, run computations, that's kind of HPC at Azure. And AI comes into that from the infrastructure level, because at the kinds of technologies that you're going to deploy in order to solve these problems, they look very similar. Distributed scale out training is very similar in a lot of ways to a large distributed CFD workload. And so that's kind of what our team aims at. And so, yeah, we work with everybody from some of the biggest banks and insurance companies in the world to the biggest, movie and special effects houses. But on the other side, it's the largest drug companies, energy companies, autonomous driving companies, you name it, and we work with them.
So it sounds like, really, if I hear you describe that range of things, it sounds like we're not really, I mean, I'm sure there's some enhancements here, but we're not really so much worried about what's the workload you're doing inside, but we're about making sure that you don't have to worry so much about managing the virtual machines and the storage and the memory that's underneath, right? We're trying to take that complexity away from you.
Sort of. So it's
Okay.
I don't say it's tricky. It's more that there's a variety of use cases. So, okay. One thing that kind of unites almost all HPC workloads and AI workloads at scale, especially, is they're optimized, and it's like these are F1 cars. These are very tuned systems. And the reason is these workloads are usually extremely valuable. A bank or an insurance company might have to do regulatory runs. If they don't generate certain calculations that they can report to the government on time and correctly, like that could be significant penalties. There's very, one of the companies we worked with, the manufacturing company, they were able to cut their product design time in half by moving to cloud, and we can get into that later too. And so these R&D workloads and other kind of workloads are very, very valuable. And so these customers traditionally made a very large investment in these on-prem systems. It could be a couple $100,000. It could be many, many millions of dollars. And so they wanted to get the most out of it. And so they're very tuned. And so when coming to cloud, a lot of times they have specific needs. They have a list of technologies and they need all of them. This is a complex system and they want to move to Azure. We've done a lot of work to support a broad variety of the technologies they already use, so that they can kind of conceptually lift and shift what they do right into Azure. We have this list of accomplishments on the hardware side, going back, I think 3 or 4 years now, that we at least keep track of. And it's like we were the first in cloud to deploy, a certain technology like the AMD Rome processors. We were the first ones to scale to 20,000 cores to 80,000 cores, above. A couple of years ago, or actually I think it was last year, we had the number 10 computer in the top 500 list, which is a kind of a, they measure supercomputers around the world, and we had a number 10, and then we had 4 more in the top 50. And the thing is those weren't like special machines that we set up for that. We just provisioned a supercomputer inside of Azure and then ran the benchmarks and made the list. So we basically meet the technological bar for our customers to run those optimized workloads. And then on the software side, exactly what you said, we try to simplify some of that so that they can, a lot of it's around simplifying Azure. It's really more like, you want to auto scale these environments up and down. That's obviously not a problem you have on-prem. You want to do, and then to your point earlier about logging and monitoring and all that stuff, doing that in a very large, if you have 80,000 cores running and they're coming up and they're going down and whatnot, that's a much more challenging logging problem. I mean, you guys get this, but the analogy I always use is if you want to go to the movies or dinner with like 2 friends, like that's easy. You kind of text each other, whatever, WhatsApp, whatever, and you just go to the movies. If you're doing like a birthday party for 10 or 20 people, like that starts getting like, there's some planning involved. Well, now you're doing a wedding. There's 100 people, there's 200 people. Like that's kind of how these systems work. Like when you want to run a couple, that's not hard. But then when you want to go from say running at 2,000 cores to running at 20,000 or 80,000 cores, like that's a different level. And so that's the part where we try to provide software infrastructure that goes along with this amazing hardware infrastructure that we provide. That is really what kind of unlocks our customers. One thing, and maybe not to get too technical, but for these tightly coupled workloads, those are like weather modeling and others, it's actually the connection between the computers that's the gating factor on scale. And this is distributed training and all these kinds of problems. So when you want to run above a certain threshold, adding more memory, adding more processors will actually make you run slower, because it's the connections between them that are essentially the problem. And so Azure deploys InfiniBand networking. And so we're kind of unique in deploying what is, a very common networking fabric at supercomputing centers and other research institutions. And that's what allows us to kind of break these scale records and really kind of play with the big boys, or we are one of the big boys at this point. And so that separates, say, like risk modeling from fluid dynamics. Is that risk modeling is more about just give me the most infrastructure you can. Can you give me 300,000 cores? That's great. They're all independent. That analogy is like you're a professor grading term papers. And if you have 9 teaching assistants, great. You divide it up into into 1/10 each. It's 10 times faster, et cetera. It's really more just about getting me as much infrastructure as possible. But again, orchestrating at that scale is an entirely new kind of challenge.
Yeah, Rob, and just to go along with what Evan said, so there's no service in Azure where you say, oh, we have the HPC service and just come bring your stuff here, right? It's a combination of like cross-cutting things like compute, storage, networking, all kinds of pieces. I guess the question I have around that then is, it seems complex, like how these seem very bespoke or something like that, where people have had something you said running for a long time. How do they approach that to like even figure out like all these enhancements that we have there? Like, what's the gateway to get people to understand what our service platform is like for HPC?
It's a bit of both. So yes, there is one of my dreams is to be able to, for some users, to remove the need to concern themselves with those technical details to some extent, and that's like a future thing. But at the moment, the best thing we can do, I think, and it sets us apart, is we have much more. I'll be careful I say this because this will Bill, not signing up Bill for support. We support a lot of the commercial and open source tools that our users already use. We don't literally support them. Like if you have a problem, like so there's a job schedule. It's exactly what it sounds like. You have a bunch of infrastructure, you give the scheduler, hey, do this thing 10,000 times, and it goes out and makes sure that those things happen. If a machine fails, if something, whatever, it'll rerun it, it can apply policies. Simple thing. We have a native one in Azure called Azure Batch. It's one of the services that we run. But there's a lot of open source and commercial ones that have been used for decades that people have spent all that time kind of customizing their workloads to use something like Slurm. It's an open source one. There's another one that's commercial called LSF, just as examples, there's others. And so in the past, a lot of times coming to cloud, it was essentially, oh, that's great that you use that, but you should switch to our cloud native thing. And that was essentially a deal breaker. And so what we've done is we basically Azure enabled and integrated those technologies. And so now people say, oh, well, I want to run on this specific processor. I use this kind of storage. You already have InfiniBand networking. And my software stack is Slurm on Ubuntu with, blah, 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 that kind of thing. And we say, that's perfect. You can deploy that in 20 minutes. Come over. And that's actually through a product called Azure Cycle Cloud, which is another product that we do. And that's actually the one that Bill's team does the yeoman's job supporting. And the whole point there is that we kind of meet our customers where they are so they can just kind of move into Azure. It may not be the best way to run in Azure, but it's definitely the easiest way because it's what they're already doing. And a lot of times we've had users where the end users, the actual scientists and quants and engineers, they don't even necessarily know they're running in Azure. The organization knows they're running in Azure, and the administrators that support those users know they're running in Azure. But that's kind of the seamlessness of that transition is what helps. And then at the high end, the people who really push the kind of the open AIs and the metas and the big energy companies and all that stuff, they're super experts. So for them, they don't, at least today, they don't really want to be taken away from the details. They know how to run and optimize to get the most out of these systems. And so for them, that kind of let me just give you my stuff and kind of take care of it isn't as attractive as I hope to make it in the future. But for them, again, the fact that they can just take what they're already doing, what they trust, what they've built up, and just use it, that's that's the magic.
You hit on something interesting there, Rob, and Bill. I'm going to direct this to you because to Rob's point, and this is sort of the migration that Microsoft as a whole has been on over the last 10, 12 years now, right? It used to be if it's not Windows and SQL and .NET, like, don't talk to me, right? These days we really want people to bring what they've got. But that does raise some really interesting challenges around supporting them. And we won't get into sort of the exact terms we use to define it, but there's a difference between, hey, we'll help you, we'll talk to you if you're running, open source software, blah, in our cloud, versus, hey, you're running Ubuntu, which, man, Ubuntu, we've got internal experts. It's fully supported. How do you walk that line, Bill, as a team? I mean, that's got to be really challenging.
Yeah, thanks, Evan. I think fortunately, I've managed to hire a team of really brilliant people, that really come from.
We'll send them to this episode so they appreciate that you appreciate them.
I do appreciate them very much. They come from the HPC field. They come from academia. They are themselves seasoned experts, right? And I managed to hire people that I think are comfortable working in the gray areas and leaning pretty hard on the experience that they already have, and then pairing that with just curiosity and a drive to help our customers succeed. And that formula has been working really well for the last couple of years. And we often find ourselves in these gray areas where customers are coming to us with a product that is not a Microsoft product. It's not even a third-party product. It's open source, for example. And technically for open source, they should be going to the community, right, for that kind of help. But we really work hard to try and make sure that everyone succeeds. My engineers are always coming to me saying, can we get more training on this scheduler or that scheduler? We want to know more. We're getting questions about this, right? So they're curious. They want to help. And we've got, I think, one of the best relationships I've ever seen between a support team and the product group, right? Rob has said many times that he sees our team as a direct extension of the product group, and we feel that support, right? So, when we're challenged and we get to a point where maybe we're not able to solve a problem, we're able to bring that to Rob and the other people in the product group, and they work very closely with us. We have regular meetings with them multiple times a week. Different triage meetings and planning meetings and so forth. And so we're getting great support. We've got great people, and we're comfortable working in the gray areas. Maybe more so than some of the other teams. And I think that's a good formula for success.
Excellent.
As a anecdote to support Bill's point there, I don't get to be as hands-on as I used to be. And so there are times where I will actually go to Bill's team and ask them questions about the products. I mean, because nobody understands the products better than the people who are hands-on answering questions for others.
Yeah, they're using it every day, right? At that point.
Yeah. We also, touching on this, so there's two actually things that are really interesting about the way we support our users. One is we aggressively want to make space for our partners in a real way. And so there are companies out there that do commercial support for some open source tools. There are companies that, we have commercial partners. And basically, IBM has some very popular products in certain industries around job scheduling. And so we worked with them to kind of officially establish kind of integration between our stuff and theirs. A lot of our partners were scared. With cloud native stuff, they feel like you're trying to replace me. And so with our platform, we have native offerings. If it's an infrastructure type thing, we're going to have a service because it just makes sense for what we do. But at the same point, we want to make space for our partners. And so when it comes to support, our model is, we're going to help our users as best we can, but we basically, that's a question about Slurm. By the way, have you met SkedMD, the company that does commercial support for Slurm? We'd be happy to introduce you to them. And we have a very good relationship with our partners. They help us understand and they help us with integration. And then in return, we make space for them and we try to help them meet the users that actually want to use their products. But then kind of tailing to that, the thing Bill has built that's impressive, and I'll compliment you for this, Bill, so that you don't have to brag. His team is a bit unique. HPC and AI, this is are you using GPUs, different VMs, storage, networking, all that stuff, and then the software stack and everything. It used to be when you'd send in a support ticket, you had to pick the technology that you wanted support from. Was it Linux VMs? Was it networking? Was it Azure NetApp files? Was it blob storage? Whatever. It's very specific. Well, if you're running an optimized system that's using 20 or 30 different technologies,
all those,
that puts the burden on the user to figure out what's going wrong, and that was obviously a very, or could be a very frustrating experience. And so what Bill's team does is they are experts at the whole concept, and it's a very broad amount of knowledge that they have to have, and they can help users figure out where the problems lie. And then if they need help from the Azure NetApp Files team or the HPC Cache team or Linux VM team, whatever, they can then work within kind of Microsoft to do that. And that has been, I think, a huge, measurably huge improvement in customer satisfaction and support team satisfaction as well, and kind of across the board, because you no longer had a networking engineer who didn't even know what InfiniBand was because they're used to front-end networking, getting these questions from users. And so Bill's built something very special, and it's a combination of the people he's attracted and the way he runs his team, and yeah, it's awesome.
Yeah, I have a question both possibly both for Rob and Bill here. When I am a software engineer, and back in the day when I did some HPC, we used, I think it was the message passing interface pattern, which requires all the nodes to rapidly communicate with each other. So, question is, do we kind of support that pattern specifically on HPC? Yep. Is there like some sort of a special tuning that we've done to kind of enable that? And then B, for Bill, also, when you do get a support case that involves MPI, how do you go about even tracking down where the problem is?
Yes, we do. So for just real quick on the technology side, so among the VM families, we have our general purpose SKUs, D, E, F, et cetera. In HPC, or specialized or workload optimized, whatever the current term is, the H series and the N series are the two kind of HPC SKUs. The H series is CPU-based compute. N series is accelerators, typically GPUs, but could be other things. And that includes accelerators across the range. So it could be for visualization, and that could be for remote desktop, but it could also be for high-end CAD. It could be for, and kind of every other visualization need. It could also be for compute or for distributed training. And so you have kind of all the different bases covered there. All the H and, well, almost all of the H and N series, all the N series for compute and distributed training, and all the H series are connected by that InfiniBand networking. And then we curate some HPC VM images that have the right drivers and everything else installed. And we support things like OpenMPitch and Intel MPI and all the different MPI libraries that people want to use to do that work. And yeah, and you don't have to run MPI over InfiniBand, but that's the performance thing we talked about earlier. So yeah, we try to simplify that part of the stack for our users. And I'll leave it to Bill to talk about how he supports users that have questions about that.
Yeah, one question I had too, maybe this is for both of you. You mentioned open source quite a bit here about how we work really good with open source software and accommodate it and things like that. I guess maybe could you give us a view into like what also like from the open source side? So for instance, if we have an open source package that we can then optimize for storage or networking or something like that, but it requires us to basically PR back to those things. I guess my question is like how much of that's going on as well? Are we contributing back to those open source projects and in order to make them work well on Azure? Or is it more like we're trying to change Azure to make them work with that? I'm sure it's a combination of both, but some insight there would be cool.
It's a combination of both. There's definitely contribution that goes back. Sometimes it's not as simple as a PR, like an open source project, like I'll use Slurm. Slurm is commercially developed by SkedMD. So it's an open source project, you can use it, et cetera. But it's not, they basically control the source code. So you can submit pull requests and other changes back to them and they can incorporate them or not. With them and with other companies, Altair is another partner, and like I said, IBM, it tends to be a little bit of more of a relationship with the company that does the development. So we actually we're very careful to not push for things that are Azure specific. So we try to stick with things that, hey, this is really good for you. And by the way, we'll then take advantage of it in Azure, that kind of an approach. When it comes to more open source applications, we've worked with a bunch of universities that tend to curate those to try and make them better or to at least submit changes back. It usually sticks to being more cloud friendly. And we're just confident in our offerings to feel like, well, we'll get the most benefit out of that, or it'll benefit our users and it benefits the community. So great. I think we're looking to do more as kind of our business grows, our team grows and whatnot.
It sounds a lot, we were talking about an AKS CSI release for Blob. It sounds like the model that y'all are using in this HPC world is very, very similar to the AKS world, which AKS is not a Microsoft thing. Mm-hmm. I'm sorry, I said that wrong. Azure Kubernetes service, AKS, is a Microsoft thing, but Kubernetes itself is not. And it sounds like what you're describing with HPC, on Azure and Cycle Cloud is about sort of making Azure, successful and making customers using Azure successful in those spaces, but you're still heavily involved. It sounds like with the community, Bill's team is very fluent in, open source, like we're working with the community and with that audience rather than, harkening back to some of our older days where, we would have said, nope, sorry, you don't want to talk .NET. We're sort of not here for you. But it sounds like very, very much a partnership with that community across the board.
Trying to. I mean, it's yes.
Not always smooth. Especially, yeah, absolutely.
Yeah.
But
well, more just, there's only so many of us. And so it's our aspirations are to be more involved in the community. And we definitely are in a bunch of areas, but a lot of times it's more ad hoc. A customer comes to us with, and by the way, we also work very closely with our technical field. So we have the HPC GBBs and the kind of HPC focused CSAs and others. So a lot of times they're the ones also driving a bunch of that. And so you'll see the GBB community, because they're working directly with the customers often. And so they'll work with us, but give them a lot of credit on some of the changes that they drive or that they publicize. But yeah,
GBB is just for the audience. GBB is our global black belts. This is our cloud solution architects that are specialized in these areas, working with our customers directly. Sorry, Rob, go ahead.
No. That's I forget to expand my acronym sometimes. But no, it's yes, we're trying to be involved in the communities, and we tend to focus, for obvious reasons, on the ones that our customers bring to us, that our partners bring to us. But yeah, the goal really is to help make this simpler, and so that applies kind of across the board.
Awesome. Yeah, I know this is great. I mean, I think it really, again, you guys may not necessarily be regular listeners, but our regular listeners will be, will remember. We were joking before the show at, how many episodes we had, how long we've been doing this. This whole world used to be called, Windows Azure when it started. Now it's Microsoft Azure, and we went through the the little button. I had back when I had an office in a Microsoft building, I had the little I love Linux or Microsoft loves Linux buttons that were floating around. Like this evolution is true, and you guys are absolutely on this evolution as well. Like you're part of that. Any last thoughts that you guys want to leave the audience with, either Bill from a an experience and a support side, or Rob from a a product perspective?
I'm never short for words, so I'll give Bill a shot first.
Well, I just say again, I've heard that this is pretty much a unique situation that we're in, right? Having a dedicated support team for high performance computing. I think it's a real advantage that Microsoft offers to anybody who's looking to run HPC workloads in Azure. And so I think it's great for us to get that out there. My team is global. I've got engineers in 7 countries around the world right now, and so we're helping. I even have my newest engineers in Japan. One of the big requests from customers in Japan is that we had local language support, and so I'm thrilled to say that we finally met that, even with a team that's as small as mine. We've got local language support, and we've got a lot of HPC users in Japan. So that's really very pleased that we're able to do that. So I think the strong relationship we've got with the product group, the great people I've got from the field and academia, their willingness to engage in multiple languages around the world. Just really happy that we've got this team, and and excited to see the growth that we're going through, right? Rob's got the numbers, but the anticipated growth over the next few years is exciting, and so really looking forward to seeing where we go with this. And yeah, it's been fun so far. Looking forward to seeing what comes next.
Great. To be clear, that's a continuation of what's been happening. It's not us hoping that it starts. It's been a wild ride. On the product side, we got a lot of great stuff coming. We'll be talking about it more, I think, later this fall, just because of the way we talk about stuff publicly. But I will say that pay attention to space. There's a lot of amazing things coming. It's been, it's one of those engineering projects where a lot of the work is under the hood, and it doesn't seem like there's a lot going on, but then all of a sudden the foundations are there and it starts kind of popping. And so we have 3 products today. HPC Pack, which has been around since 2005. We have
it was on-prem originally, wasn't it?
It was, and still is. It still
Okay.
is, yeah.
Okay.
So HPC Pack is just a scheduler. It's old school. It's Windows focused, but it supports Linux too. To your point, it has a relatively small but dedicated user base. Then we have Azure Batch. It's a cloud native scheduler. It runs batch workloads in Azure, and then we have CycleCloud, supports third party. CycleCloud also supports hybrid. If you want to run workloads on-prem and in Azure, CycleCloud will absolutely support you in that. And so those products form the basis of our platform, but that whole platform is going through a major evolution. And so, yeah, we're really excited to talk about that later this fall. But anybody who's interested in those details, I've done a bunch of talks on YouTube, and they go into the specific products and the features and all that stuff. So if you want to kind of geek out on that stuff, it's all available. But obviously, I enjoy talking about this space.
I've got 2 notes to myself. We'll get these links from you, for the audience. And I'm penciling in that we'll follow back up in the fall after y'all release some of this stuff, and we'll get you back
awesome
to talk about it at that point as well. So awesome. Okay, great. Kale, Sajid, any last questions for Bill or Rob?
No, this is great.
Thanks for all the details, Rob, and background of on the offering and how you guys work to create better and better services for Azure. So thanks for all that detail.
Sure, anytime. Thanks, you guys.
Folks.
Appreciate it.
Thanks for inviting us.